Assalamualaikum warahmatullahi wabarakatuh and greetings to all. I am Sri Alifah binti Dahnel from Polytechnic Kota Kinabalu. Today I would like to present about my research, which is the construction of an EMG signal conditioner circuit to study the signals on biceps brachii muscle for individuals of different lifestyles and sizes. This is the overview of my presentation, which consists of introduction, literature review, methodology, implementation result and analysis, and conclusion. Electromyography, or also known as EMG signal, is a principal method of providing more data on muscle activities. The purposes of EMG signal are to control various rehabilitation devices or prostheses and to determine the extent to which conditions, disorder, and injuries of the nervous and muscular systems. The objective of our study is to test the ability of a signal conditioner circuit in processing raw data of EMG signal obtained on biceps brachii muscle for individuals in different styles of living and sizes. There are two scopes here, which are to healthy, non-athletic male individuals of the same age but different lifestyles and physical sizes, and the physical size and body fat are measured using body mass index or BMI and through circumference measurement at the biceps. Here is the criterion for our subjects. The person A has the BMI of 27.2 and the bicep circumference at relaxed condition is 28 cm while contracted condition is 33 cm. The person A is rarely doing the physical exercise. Meanwhile, the person B has BMI of 22.6. The bicep circumference at relaxed condition is 24.5 cm while in contracted condition is 26 cm. The person B is regularly doing the physical exercise. Thus, we categorize the person A as overweight and inactive person with higher fatty tissue, and the person B is normal and active person with lower fatty tissue. Our study is based on few studies that found that the presence of fat layer also influences EMG signal characteristics. By reducing the fatty tissue, the EMG signal could be improved in its amplitude. Various parameters of EMG are higher in healthy professional athletes compared to non-athletes, possibly due to changes in secondary muscle fibers as a result of training. A research by Jingpeng, Li Qiong, and John wrote that the EMG signal is frail with undesired noise. Hence, before it can be used in various health applications, it should be carefully processed through signal amplification and filtering to minimize the noise component while retaining as much information from physiological EMG signals as possible. In order to conduct our study, the surface electrodes that we are used is silver chloride to record the data from the muscle, as they create less electrical noise due to low impedance contact with the skin. Here is the architecture system of our study, which consists of the input system that come from the electrodes, which provide the data to be processed by the processing system that will amplify the low signal and filter out the unwanted signal, and the data can be read through the oscilloscope at the output system. We designed our study based on this signal conditioning system, which consists of the input, instrument amplifier, the high pass filter, low pass filter, and the output. Based on the signal conditioning system, we constructed the EMG signal conditioner circuit like this. There are two electrodes placed on the biceps brachii, while another one is placed near the elbow as reference electrode due to the electrically inactive there. In order to record the EMG signal, we set up two conditions. At the arm position is at 180 degree, 90 degree, and 60 degree, and the conditions are relaxation mode when there is no load or force given, and contraction mode, which requires the subject to make a firm hold and enlarge the palm repeatedly to contract the overall muscle of the arm. Here are the results of our study. The left column shows the result for relaxation mode at 60-degree angle, while the right column shows the result of contraction mode at 90-degree angle. Both results shows the person A with higher fatty tissue recorded a lower amplitude signal compared to the person B. The detailed findings are recorded in the table for both conditions in terms of frequencies and VRMS. For relaxation condition, even though there is no load applied, the readings are increased due to the movement and muscle tension detected by electrode when we bend the elbow from 180 degree to 90 degree to 60 degree. Overall, the person B recorded greater value compared to the person A for both conditions, either in frequency and the VRMS. And the contraction condition gave the greater value compared to the relaxation condition. We found that the more forces and contractions exerted on the muscle, the greater the amplitude of the resulting EMG signal. However, the values recorded were not indicating a large gap of difference for active and inactive individuals. From the results that we have obtained in our study, we can prove that the thickness of subcutaneous tissue affects the amplitude of EMG signal because the amount of excess body fat is considered as an internal noise for EMG signal. These findings also take into consideration that the frequency of exercise as well contributes to the changes of muscle activities. Despite of having the result, the information obtained is limited and its actual content is difficult to extract. In order to improve this data in future research, we recommend other researchers to use many other types of electrode with multiple channels for different muscles at the same time instead of using single type of electrode. Besides that, the researcher can consider a larger number of samples with diverse criteria such as individuals of similar lifestyle but having different BMIs and etc. That's all from me. Thank you.